Right now, millions of people are asking AI a question and getting an answer back in seconds. It feels effortless. It starts with an empty box. You type a question and hit enter. That becomes a single request, one small packet of text. But behind that little box sits one of the most complex machines ever built. So let's follow your question and see what it really takes to answer it. This is the path. From your keyboard to the edge, through the gateway, into the GPU core where the answer is made, and back to you. Thousands of GPUs serving many models to millions of people all at once. First, the edge. Your request lands at the data center nearest you. Anycast routing and a global network put compute physically close, and everything is encrypted in flight. Then the gateway checks you in. Is your API key valid? Are you within your rate limit? Abuse gets stopped right here before it costs a thing. Now the router picks your path, which model, which region, which pool of GPUs, and it tries to send you to a machine that already has your conversation warm. But before anything runs, a fast classifier scans your input for attacks and for abuse. And your answer won't arrive all at once. It streams back token by token over one open connection, which is why you see words appear as they're written. Now the core, where the real work happens. Your words become tokens, numbers the model can process. First, prefill. The whole prompt is read in one massive parallel pass, and every token's attention is saved into the KV cache. That's the wait before your first word, the time to first token. Then decode. The model writes one token at a time, and each step streams the entire model's weights out of GPU memory. This isn't limited by math, it's limited by memory bandwidth. So the whole core is built around one obsession. Never let a GPU sit idle. Continuous batching rebuilds the batch every single step. The instant one request finishes, another takes its slot. That alone can lift throughput more than 20-fold. The KV cache is managed like a computer's memory, split into fixed pages so almost nothing is wasted. And identical prefixes are shared for free. Prefill and decode even run on separate GPU pools, because they stress the hardware in opposite ways. Models too big for one chip are sharded across many, wired together with high-speed links. And tricks like speculative decoding and quantization squeeze out even more speed. All of it runs on engines like VLLM and TensorRT, on fleets of H100s and H200s, chips with terabytes per second of bandwidth kept fed every millisecond. None of this runs blind. Two numbers matter most: time to first token and the gap between each token after it, tracked on every request, every model, every region. Every chip reports its own utilization, memory, and temperature. And distributed tracing follows one request across every hop. So when something is slow, they can see exactly where. It rolls up into dashboards and hard targets, and if one is about to break, it pages a human before you ever notice. And every token is metered, because every token is GPU time, and GPU time is money. Wrapped around everything, security. Every request is authenticated, and one customer's traffic is isolated from another's, even when they share the same GPU. For sensitive use, prompts can be processed and never stored, and personal data is detected and redacted on the way in. And because these models can be tricked, an instruction hierarchy keeps user text from overriding system rules, and classifiers catch injection and jailbreaks. Any code the model runs is locked in a sandbox. Everything is encrypted, keys live in dedicated hardware, and the whole platform is audited against standards like SOC 2. Here's a subtle problem. The model itself is stateless. It remembers nothing between turns. So how does a conversation stay coherent? Every turn, the whole history is resent. but rereading it would be wasteful. So the KV cache is kept warm, and sticky routing sends you back to the same machine that already holds it. When a conversation outgrows the context window, older turns are summarized. Long-term memory persists across sessions, and retrieval pulls in facts the model was never trained on. And all of it flexes. When traffic surges, GPU pools scale up, spilling across regions and even clouds. When it's quiet, they scale back down because idle GPUs burn money. Which brings us back to your request. Authenticated, routed, batched, generated, monitored, secured, and now the answer streams home, token by token, into that same little box you started with. That's what it takes to answer one question at the scale of millions. Thousands of GPUs, dozens of subsystems, one quiet packet of text. Thanks for watching. If this helped, follow, like, and share. And I'll see you in the next one. Bye.